Hi everyone. My name is Daniel Phillips. Today I'm going to be talking about building virtual file systems for a WebAssembly first environment. A little bit about me. Dan's fine, Dan Phillips. I'm an engineer, and I'm also the Wasm lead at a little company called Loophole Labs. At Loophole, we're an early stage startup, been around for just over a year-ish, and I'm here with the founder and CEO, Shivansh Vij. So if you see us around at places, feel free to talk to us. We'd love to talk to you about networking and, of course, WebAssembly. I also started and run the Wasm Chicago group in Chicago, so if you're ever in town, we would love to have you come speak or come check it out. We also do everything at least virtually, if not hybrid. We're trying to get back to more hybrid stuff up in this sort of post-ish pandemic time. You can check that out at wasmchicago.org. And on the internet, I'm D_Phila, pretty active on Twitter in sort of this area. Okay, so let's get right to it. So the problem, what to do about file systems. There's been a lot of talks about all these different serverless platforms and all sorts of things that are utilizing Wasm. We've talked about containers and how Wasm can fit into that ecosystem and their relationship, but file systems still don't exist in WebAssembly by itself, right? So applications need them, right? Wasm alone, just Wasm, does not have them. If we think about sort of a progression with using file systems from the bare metal days to VMs to containers, it makes sense to explore this topic, and we're going to kind of go into some of these current approaches and talk about some other interesting things that we've experimented with. This is also going to be sort of an exercise in why not driven development. One thing that I really like about the WebAssembly community is the sort of spirit of invention and trying things new. Bringing things that were designed for the browser and then saying, hey, that's a perfect use case for server-side as well. And so in that spirit, we're going to kind of use that as a theme. Right, so to start off, we're going to start with POSIX and the current non-WASM state of affairs. So POSIX is the Portable Operating System Interface. I found out in preparing for this talk that I am the same age as POSIX, which was made me feel old and young at the same time, which is kind of cool. So I don't think I need to go too deep into what POSIX is for this room, but basically it just really defines the interface, right? And so it defines the interface. This is typically done through libraries that exist, which we typically call libc, right? Libc, there are different implementations of this, and then also below that, syscalls. There are also virtual file systems that exist in Linux now, right? And so we're going to kind of talk about how they came to be briefly, and then talk about how they might fit into the new paradigm. But basically, they're an abstraction layer currently in the Linux space between user space and the underlying file systems, right? Like the actual storage devices. And the underlying file systems can include network file systems, block devices, et cetera. Right, so nothing like a diagram this dry to start things off with, but if you can see in the center, there is a sort of giant VFS block, and inside that you've got block-based file systems, stackable network. You've got Fuse in its own little corner, maybe where it belongs. It's hard to say. And then you've also got pseudo FSs, which are typically VFSs as well. We're not going to talk about like all these different layers, but basically the idea of a VFS is to standardize the approach to working with file systems, right? Not just the interface, but like what kind of API behavior we expect, and to make it so that it is not super different depending on the sort of actual I/O that's happening, right? So within the WebAssembly space, we're going to talk about some of the current approaches. And most people here will know about WASI, right? So WASI, first and foremost, is making a lot of progress, and this is something that most people are thinking about when they are deploying Wasm applications server-side. How can we access underlying resources? WASI does this by providing scoped access to the host file system. And I'm not going to get into the weeds on that. There are plenty of other talks in that space. And it uses the WASI libc library, which is sort of a Wasm-focused set of libc bindings based on Muscle, I believe, which is a flavor of libc. There's also, if you go back even further, some of the people here might remember the Emscripten VFS, which is still well documented and alive and well. It's a web-first VFS on top of JS primitives. This can be backed by storage options in browsers like IndexedDB or local storage. And this actually has pretty great support for C and C++, right? The interface here is also, from my research on it, is also an adapted muscle libc. So then there's another project that a friend of mine worked on. It's called WASI VFS. Yuta Saito is a Japanese developer, and he is instrumental with Ruby support for WebAssembly, specifically WASI support. He also works on Swift support for WebAssembly. And WASI VFS is an in-memory Wasm-embedded read-only VFS. And he built it so that he could demo using Ruby applications in the browser with WASI shims, right, with a WASI polyfill. So kind of a cool idea. Right now, it's only read-only, but he does want to add write operations. And this also is similar. It hooks WASI syscalls and uses WASI. It's pretty tightly coupled to a WASI runtime. So the sort of crux of this talk is why not take this sort of progression a step further? If we think about WASI actually accessing the underlying host, we think about Emscripten using JavaScript primitives, and then we think about WASI VFS using in-memory WASI. Why not think about a different abstraction, right? So if we go back, Linux abstractions, we have kernel space and user space. We have libcs, we have syscalls. We have context switching, which can be expensive. So what's possible, right? Like I was saying about the sort of spirit of this group of people is maybe we should and can question all of the assumptions all the way down. So I'm going to talk about a little bit of exploration that we did. What if, I'm just saying what if, we took a libc-like implementation and made a Wasm-first libc and then also a Wasm-first VFS. Why? Many programs rely on a libc interface for file I/O, right? Like maybe trillions of dollars worth of software currently relies on these operations, spanning decades. This could also theoretically give us freedom from an underlying host. And that could also, in theory, open up sort of a new polymorphic experience with WebAssembly where maybe it doesn't matter as much if it's server-side or client-side, or if it's on an IoT device, or if you switch runtimes, right? As long as the runtimes are meeting the WebAssembly spec, maybe we could run something like a VFS there. So non-rhetorically, though, why not? Like, why should we actually not do this? It's a lot to reinvent. This would be a lot of work. File systems are complex beasts all by themselves, and there have been many iterations going back decades that people have worked on, people much smarter than me, and there's a lot of work to do, and it would just be a mountain of work. Also, there are the constraints of the environment, right? You have the constraints of the WebAssembly runtime, you have the constraints of module size, and then below that you have actual constraints of it being in memory per se. And then, right, like I mentioned, alternatives already exist, specifically advances in WASI. And at this point, I'd like to point out that I talked with Dan Goman last night, and he told me that he would like to talk to me more to convince me to never ever try what we're about to explain. and I actually think I agree with him. And so I'm going to just kind of talk about the exploration that we took in this space, and maybe there's an edge case somewhere where someone could find some value in it. Yeah, and then a disclaimer to go along with that last comment is that I don't really know much about file systems, right? So like, I'm not a file system developer. I write a lot of Rust and a lot of Go recently, and I'm pretty well versed in like the WebAssembly stuff with Rust, but I'm not like an old school Linux file system hacker. And I'm hoping to sort of highlight this in the next few slides. So to start, a libc is needed, but which one? Really, we just need to satisfy the interfaces, right? So when we first started looking at this, like we were like, OK, everything else is fair game. Let's just get the interfaces, figure out how to deal with the FFI, the types. And then from there, we were thinking, OK, why port abstractions from a system with different constraints, i.e., the abstractions imposed by the Linux convention, right? So when we think about user space and kernel space, we don't really have those concepts within a Wasm environment, right? A lot of things have been ported over. Obviously, they exist below that layer, but within this compute space, maybe we can do without them for now. So keeping it simple to start, we just tried to implement open, read, write, and close, right? These like very simple file system operations. Open a file, it returns the file descriptor, read it, do something with it in WebAssembly, right? Write something to it, and then close it. So the file system itself, what could it look like, right? Again, we want to keep it as plain as possible, as universal as possible. And the elements we kind of just spitballed were implementing basic FS calls, structure, reading, writing, permissions, et cetera. And we got close to most of these, right? And then I made a joke about Fuse earlier, but people might ask, is this another Fuse? Fuse is a file system in user space. It's a very contentious sort of file abstraction. And I think that like it really depends on how we approach this. And again, we're going to try to not borrow abstractions from previous constraints, e.g. Kernel versus userland. And then really, it's virtual only by virtue of being in a WebAssembly environment. Other WebAssembly modules, or if you're thinking about components with the possible future with a component model, need not know that it's a WebAssembly VFS. It's just a VFS, right? It's just file operations, right? Literally just syscalls on storage within limits of a Wasm module under a libc. The fewer abstractions that leak, the better. And finally, Wasm and serverless, we've heard a lot about that, especially if we were talking about that at the Docker meetup last night, too. Wasm is such a perfect fit for serverless with cold start times and all these other things. And so figuring out sort of the file system part, maybe a slim sort of ephemeral Wasm-first file system could be a better fit in some situations. So I'm going to give a demo, which is, I'm going to do this in a second. But first, this is a link to a thing that we released last week. We released a tool called Scale Functions, which is a function runtime for WebAssembly, where you can, we have support for Go, Rust, TypeScript, and I'm going to use this for our quick demo here. Yeah. Also, I'd like to thank Shiv for the sweet QR code graphic that he generated with this. So, with that in mind, a scale function is basically a serverless function, right? And so when you generate run using the scale CLI, it creates this scale file, which is basically a config file. And you can see here, pretty basic. What version are we using? Right, we have tags, signatures we'll get into, what language, the dependencies for that language, and then the source file. So in this file, when you generate a scale function, you get a function called scale, right? A scale function. And that's what starts on line 4 and ends on line 20. And everything else, for the most part, is specific to this talk. But we also wanted to keep these abstraction layers as clean and as not needing to know about WebAssembly as possible, right? So you make a scale function. The scale signature HTTP deals with all of the serialization to and from the Wasm environment. And basically, the CTX wraps the response and the request, and then you can do stuff to those. You can also do chaining. It's a very good solution for middleware, which is actually kind of the genesis of this project. So you can use middlewares from different ecosystems, chain them together, and then run them all from whatever runtime we have. Currently, we have a Go runtime, and we're also working on support for other runtimes, right? So yeah, so besides that, what we're doing with the file system itself is, I said no leaky abstractions, but here we are. Initializing the globals, which what this does is it initializes the file system and a process model so that we can sort of interact with these things like we would actual syscalls. And then from there, what I'd like to do is open 50 files, right, name them, and then just return the file descriptors. Pretty simple. You'd be able to do this on OS, and then if you wanted to, you could check LSOF, LSOF, right, to see which files were open, right? So I'm going to do this quickly. OK, can everyone see that still, kind of? All right. I already built this because I didn't want to take any chances. So if I were to build this Rust code, it would pull the dependencies from our registry, and then it would build the Rust code here. Under the hood, it's building it to WASM32 unknown unknown. And like I said, the runtime is written in Go, so it comes with a HTTP server out of the box. So you just do scale run WASM VFS latest, and now it's on port 88. And let's see what we get. Great. OK. So here it printed out all the file structs with the different inodes, the file descriptors, and the paths that were generated, right? And one thing I'd like to point out is that here on line 12, right, this is plain old standard library FS, right? So if you're writing Rust and you want to do this and you want to add this to your scale function, it just thinks it's opening a file. There's no other magic. You don't have to tell that it's WebAssembly. It just opens it like it would and returns to you the metadata about the files which were opened, right? I point this out because, like I've said this a few times, but this is very important to us to sort of keep the developer experience, in a nice sort of palatable environment where they don't have to worry about the underlying infrastructure. So this is just the docs for that file implementation. Oh, last thing. One more thing. This is all from a spike, and it's like obviously pretty gross and dirty, right? So what I did with this is, if you're interested, I pulled the libc bindings out and I threw them up on GitHub. So these are the libc bindings. You have to do a little work yourself to get these to work, but they're basically just like small libraries. This is also the VFS implementation, which you can check out, which breaks out the file system and the process models also. Cool. OK, so there's some unanswered questions, though, right? In-memory VFS, what about persistence? This doesn't really answer any questions about actual persistence. So one of the ideas, this is really just spitballing here. This is also beyond the scope of this talk. But from here, what you could do with this maybe is a couple possibilities. The first possibility is that a module loads the state on instantiation from a centralized source of truth, maybe even another VFS, actual file system on the host, or another module, like a stateful module, right? This can be done. There's some drawbacks to this. If your actual data is too large, there's going to be some startup costs, right? But there's some tricks you can do with pre-initializing, things like that. This is a viable option for some cases, especially for serverless functions that may just need something loaded quick and small and usable, right? Possibility 2 is a little bit more complex, but ooh, sorry, that was not a good idea. A stateful, maybe like a stateful WASI component that is a VFS, right? That exports it, that this could be a component, and that's important because this could expose a resource handle to a WASM-only application or a variety of WASM-only application instances that all talk to the WASI module, and then when the application instances shut down, they do a quick signal to update the state on the actual VFS module, and then that can also transmit state to the actual host. So this is kind of like a partial sandboxing model, right? Maybe you're at an institution where they don't want you to have access, even the possibility of access with WASI, right? And so you could say, oh, that's fine. Our actual applications are WASM-only modules, right? And so this kind of brings up some other questions, which is how ephemeral does a stateful component need to be, right? This second possibility, actually, if you squint hard enough, kind of looks like maybe it's kind of how the kernel implements VFSs, right? As this virtualized layer between the actual, say, block devices, right? This could actually standardize file operations from WebAssembly components to some sort of underlying persistence layer that is below the actual WASM or WASI runtime space, right? Yeah, so a stateful layer could span several related or recurring application instances. There's more exploration that is needed here, of course. The future. So again, why not, right? And this is more on the rhetorical side, right? Why not try this? In-memory DBs are already used as primary databases. Redis is a great example. I love Redis. Also, Redis is such a great, the source code is so beautiful. There could be other iterations of things like this as WASM-first components. VFS has already helped to standardize storage interactions in kernel implementations. Why not in this paradigm, right? Why not at least have some sort of layer if it can help make interfaces easier for people not having to deal with how the sausage is made, right? And then linking to persistent storage then kind of gets pushed to the problem space of distributed computing, right, if this path is pursued. This idea is like, OK, let's just try to solve one little thing and solve it well. And if we can do that, then there's a whole other space where other people who are much smarter and better at distributed computing can figure out how these stateful services should talk to, say, IPFS or other network storage or block devices, et cetera. There are more challenges, because as many people here know, there are many flavors of libc, which wrap even further varieties of syscalls, which interact with vast types of real and non-virtual and non-WASM, virtual and non-WASM file systems on even more types of platforms, right? So how could this be managed? In the time I have left, I'll just kind of talk to you about some ideas in that space, too. One way is with unified tooling. So instead of saying, hey, we're going to support every platform, every type of libc, every type of file system, why don't we start with the actual module itself? And if we could apply some sort of strace-like tool to an arbitrary WASM module, then maybe we could figure out which syscalls are needed, which libc implementations are needed. This is outside of the scope of this talk, but I actually have a small prototype of this that I worked on earlier last year. And actually, if anyone's going to be in Amsterdam, I'm going to talk about that very briefly at WASM Day at KubeCon. So hopefully we'll have a demo that's good by then. So if we had this strace-like tool, maybe we could do something like generate bespoke and unique VFSs and libc-like implementations for novel WASM modules, regardless of the platform that they were generated on, and only implementing what is needed for a given module. A given module, not a give module. This allows for virtual platform layering, which, when contrasted with the POSIX syscall and kernel user space abstraction, kind of gives you this only what you need and nothing more. This term, virtual platform layering, comes from a talk that Luke Wagner gave last year at WASM Day, and it's on YouTube. I highly recommend checking it out, especially if you're interested in the component model. And this idea, what this can do is maybe if we're thinking about this as a force for standardization, this could be, a tool like this could be used or maybe be helpful for generating some of those layers. Things like resource and handle types could mean that only glue code is really a libc interface. Resources are more directly usable, so there's minimal syscall cost. Performance hits are also minimal. And tooling for virtualization for supporting interface plus WASM first file system generation for components could make for a decently promising future, maybe more of an interesting future if anyone decides to use it. One of the things that we worked very hard on at Loophole Labs when we were first talking about Scale last year, it wasn't even called Scale then, but was basically, we hear a lot of buzz about WebAssembly and a lot of excitement about it, but there's kind of an interesting distance for people, especially, say, someone who's only developed JavaScript, client-side JavaScript applications for their entire career. They're not going to be very comfortable seeing memory addresses right off the bat, right? They might be a little bit scared, to be honest, right? And I think that this sort of distance between the developers who work on WebAssembly, like the people in this room, and the people who could really utilize it, that gap is still pretty large, but I think there's some great work being done to sort of close that gap. And one thing that we really wanted to try to push for, and we've come close, and we're still trying to work on it with scale functions, is that WebAssembly is just an implementation detail, right? So at the Docker thing last night, I was thinking about this. I think now, I've worked in other shops in big companies that have adopted Docker. We were talking about Ruby on Rails yesterday, and how people would just shove their whole Ruby app into a Docker container. And I've seen that done, and I would say that many, many users of Docker now don't know anything about, or know very little about much of the implementation, the underlying implementation. And they don't need to, because it's such a good product, right? It just works. That's kind of the beauty of it. So if we can get WebAssembly to that point, I think there's such a great opportunity to take advantage of all the things that keep coming up, right? Like sandboxing, space, startup times, et cetera, all these things. Oh, by the way, WebAssembly as an implementation detail, that's actually, I should have put that in quotes. That's from Brian Sletton, who wrote the WebAssembly A Definitive Guide book. It's a really, really great book if you'd like to check it out. He's unfortunately not here, but I did mean to credit him with that. OK, so thank you very much. Thank you for listening to me ramble on. I'd like to thank the Bytecode Alliance for all of the great projects that they maintain. Really, really helpful, and such a great group of people. Also, the WebAssembly community group for letting me be a fly on the wall in meetings, in compiler discussions that I'm still trying to understand. And I would also like to say thanks to Yuta Saito for reviewing this talk and giving me some feedback and sort of his ideas around building WASI VFS. It's a really cool WASI library, and he's got some great demos up of it on his GitHub. And I'd like to thank Shivansh Vij, the founder and CEO of Loophole, for checking out this talk and correcting some mistakes. And then Sergio for organizing. If you've ever organized an event, you know there's so much more that goes on behind the scenes, and he's really made it extremely seamless. I'm Daniel, or Dan, at Loophole Labs. This is my email. Feel free to hit me up for any reason. On Twitter, I'm D_Phila. I usually just tweet about work stuff, mostly. So it's really just about WebAssembly and programming. And also, if you're in Chicago, we've got Oscar Peterson coming to speak, the guy who created the Grain language. And we have Jeff from Shopify came to speak last year about Wasm debugging. And so if you'd like to speak, hit me up. We do virtual, or if you're in town, we'd love to have you there. So thanks again for having me, and I appreciate it. Yeah. Before we take questions, I'd like to reiterate that I don't know anything about file systems. So, yeah. No, I'm kidding. I'm kidding.
Given that you know nothing about file systems,
yeah.
You chose a very POSIX-based approach, which is super interesting and I think really fits with your intention of, file open just worked. What do you think about something more of a capabilities related? In mind, there's 4 or 5 APIs, file system APIs for the browser that have been littered in the history.
Yeah.
And Google has a new file system access API that is standard or not standard. Where do you see this approach versus using the more of the browser approach for that?
Yeah, that's a great question. Yeah, I can't say that I know enough about the history of the browser implementations, but one thing that this approach could possibly help facilitate is whatever happens in the machinations of the browser changes, this could be a nice layer on top of that most users wouldn't have to think about that, right? So if you could have this Wasm first VFS, maybe those different implementations and the file system implementations below that could deal with vendor-specific or browser-specific API changes. Yeah. Besides that, there are real limits to. There's some interesting. I don't know exactly about the release schedule, but there's talk about host system file I/O from browsers, right? And so there's a possibility that this could sit on top of that and also maybe abstract away some of those differences. So, anybody else? Cool. Well, thanks again for having me. Appreciate it. Yeah.